August 17, 1943, 27,000 feet above Schweinfurt, Germany. First Lieutenant Robert Morgan watched his B-17 Flying Fortress, the Memphis Belle, take its position in the massive bomber formation. Around him, 230 other B-17s filled the sky, their aluminum skins glinting in the morning sun. Each aircraft weighed 65,000 pounds fully loaded. Each required approximately 12,000 pounds of aluminum just for the airframe. The fleet above Germany that morning represented nearly 3 million pounds of aluminum, metal that 2 years earlier had been cooking pots, beer cans, and automobile parts sitting in American homes. Morgan didn't know it, but the control yoke he gripped had been smelted from donated kitchenware collected in a Cincinnati scrap drive. The wing spar above his head contained aluminum that had once been part of a Buick's engine block. The fuselage panels protecting his crew from 40 below temperatures and German flak had been rolled from metal reclaimed from thousands of sources across America. His bomber, like every B-17 in the formation, was a flying monument to the most ambitious industrial recycling program in history. This is the story of how American ingenuity transformed a critical material shortage into strategic advantage, how housewives, factory workers, and metallurgical engineers collaborated to build an air armada from scrap, and how flying fortresses constructed from recycled aluminum brought total war to the heart of Nazi Germany, proving that American industrial might could turn household garbage into instruments of national survival. To understand the aluminum crisis of 1942, you have to understand how unprepared America was for industrial war. In December 1941, when Japan attacked Pearl Harbor, the United States produced approximately 600,000 tons of aluminum annually. That sounds impressive until you realize what modern warfare demanded. A single B-17 Flying Fortress required 12,000 pounds of aluminum. A B-24 Liberator needed 14,000 pounds. The smaller P-51 Mustang fighter still consumed 2,400 pounds per aircraft. The military's requirements were staggering. The Army Air Forces wanted to build 50,000 aircraft in 1942 and 100,000 in 1943. The Navy needed aluminum for ships, particularly the new Essex-class aircraft carriers that required thousands of tons each. The Army needed it for trucks, tanks, and equipment. Industrial planners calculated that meeting just the aircraft production goals would require nearly 2 billion pounds of aluminum in 1943 alone, more than 3 times the nation's total production capacity. The problem wasn't just quantity, it was speed. Building new aluminum smelting plants took years. The process of refining aluminum from bauxite ore required enormous amounts of electricity. Each pound of aluminum consumed approximately 8 kilowatt-hours of electrical power. New hydroelectric dams had to be constructed to provide that power. New bauxite mines had to be opened, primarily in Arkansas and Jamaica. New reduction plants had to be built and equipped with specialized machinery that itself required metals in short supply. The government moved aggressively on all fronts. The Defense Plant Corporation financed rapid construction of new Alcoa smelters. The Bonneville Dam in the Pacific Northwest was completed ahead of schedule to provide power for aluminum plants. Reynolds Metals, previously a small foil manufacturer, rapidly expanded into primary aluminum production with government backing. But even with crash construction programs, the new capacity wouldn't come online fast enough. Military planners faced a terrifying gap. The production facilities existed to build the aircraft. Boeing's Plant 2 in Seattle could assemble B-17s. Douglas Aircraft in Long Beach could produce dive bombers. Consolidated in San Diego could manufacture B-24s. The factories were ready, the workers were trained, but without aluminum, the assembly lines would stand idle while American forces fought with inadequate air support. The solution came from an unexpected direction. Harold Ickes, Secretary of the Interior, proposed a nationwide scrap aluminum collection drive. If America couldn't mine and smelt enough new aluminum immediately, perhaps the nation could recycle what already existed in civilian hands. Millions of pounds of aluminum sat in American homes as cooking pots, kettles, coffee preceptors, and various household items. More existed as automotive parts, building materials, and industrial scrap. The concept seemed almost absurd. Could housewives' cooking pots really be transformed into heavy bombers? The metallurgical answer was yes, with some qualifications. Aluminum alloys used in aircraft had specific strength and fatigue properties, but recycled aluminum could be realloyed and processed to meet those specifications. The purity requirements were stringent, but achievable. What mattered most was collecting enough raw material to make the recycling effort worthwhile. In July 1941, 5 months before Pearl Harbor, the aluminum collection program began as a modest effort. Local communities organized scrap drives. Boy Scouts went door to door collecting old pots and pans. Women's organizations held collection events. The response was enthusiastic but relatively small scale. Then came Pearl Harbor, and everything changed. The attack transformed American attitudes overnight. The aluminum drive went from civic duty to patriotic imperative. Citizens who'd been reluctant to part with functional cookware now eagerly donated. Scrap collection became competitive. Towns tried to outcollect their neighbors. Newspapers published collection totals and urged readers to contribute more. The propaganda machine went into high gear. Posters appeared everywhere with messages like, "Your old pots and pans can bomb Japan," and "Aluminum for defense. Turn your scrap into planes." Radio programs featured celebrities urging donations. Movie theaters showed newsreels of scrap being transformed into aircraft. The Office of War Information coordinated a massive public relations campaign that made aluminum collection a visible symbol of home front contribution. The collection infrastructure expanded rapidly. Municipal governments established drop-off points at schools, fire stations, and government buildings. Scrap dealers, previously focused on iron and steel, added aluminum collection capacity. The waste management industry, such as it was in 1942, reconfigured to prioritize aluminum recovery. Within months, a nationwide network existed to gather, sort, and transport scrap aluminum to processing facilities. What Americans donated was remarkably diverse. Cooking pots and pans were the most common items, but the drives collected far more. Coffee percolators, tea kettles, cake molds, ice cube trays, pie plates, and every other aluminum kitchen implement imaginable. Lawn furniture, particularly the tubular aluminum chairs that had become popular in the 1930s. Automobile parts, including cylinder heads, transmission housings, and engine blocks from junked vehicles. Industrial scrap from machine shops and manufacturing plants. Some donations were more exotic. A woman in Iowa sent in her aluminum artificial leg, declaring she could manage with crutches until the war was won. A restaurant owner in Chicago donated 200 aluminum serving trays. A dentist contributed dental instruments that contained aluminum alloys. Amateur radio operators donated chassis and housings. Even children contributed, bringing in aluminum toys and lunch boxes. The collected material arrived at processing facilities in wildly varying conditions. Some items were clean and easily identifiable. Others were corroded, painted, or combined with other materials that had to be separated. Sorting became the first critical step. Different aluminum alloys had different properties and uses, so materials had to be roughly categorized before smelting. Processing facilities employed hundreds of workers, predominantly women since most men of working age were being drafted. These workers sorted scrap on conveyor belts, separating aluminum from steel, brass, and other metals that inevitably ended up in collection bins. They removed handles, rivets, and attachments made from different materials. They categorized aluminum by type as best they could: casting alloys versus wrought alloys, pure aluminum versus alloyed aluminum. The sorted material went to secondary smelters, facilities designed specifically for recycling, rather than primary production from ore. These smelters operated differently from primary reduction plants. They used reverberatory furnaces that could melt mixed aluminum scrap and separate out impurities. Fluxes were added to help draw off oxides and contaminants. The molten aluminum was analyzed and adjusted by adding pure aluminum or specific alloying elements to achieve the desired composition. Quality control was critical. Aircraft aluminum required specific alloy compositions, typically aluminum with copper, manganese, magnesium, or zinc added in precise ratios. 2024 aluminum alloy, commonly used in aircraft fuselages, contained approximately 4.5% copper, 1.5% magnesium, and 0.6% manganese. 7075 aluminum alloy, used in highly stressed components, contained zinc, magnesium, and copper. Metallurgists had to ensure recycled aluminum met these specifications exactly. The challenge was that donated scrap contained dozens of different aluminum alloys, many unknown. A cooking pot might be pure aluminum. A lawn chair might be 3003 alloy. An automotive part might be a casting alloy with high silicon content. All of this mixed material had to be analyzed, remelted, and adjusted to create aircraft-grade aluminum. The process was complex, but American metallurgists proved equal to the task. By mid-1942, recycled aluminum was flowing into aircraft production at increasing rates. Boeing received shipments of aluminum ingots refined from scrap. Douglas Aircraft took delivery of rolled sheet made from recycled material. The metal arrived at factories where it would be transformed into the components of bombers and fighters. What had been a housewife's cooking pot in Des Moines might become part of a B-17's wing spar. A beer can from Milwaukee could end up as cockpit paneling. An engine block from a junked Ford might be reborn as a bomb bay door. The manufacturing process was itself remarkable. Aircraft construction in the 1940s was far more labor-intensive than today. B-17 production required approximately 20,000 man-hours per aircraft. Workers hand-riveted hundreds of thousands of aluminum sheets and components together. Each rivet hole was drilled individually. Each structural member was fitted, trimmed, and fastened by hand. The Boeing plant in Seattle became the largest aircraft factory in the world. At peak production, the facility employed over 30,000 workers and produced 16 B-17s per day. The production line stretched for acres. Aluminum sheet arrived at one end and completed bombers rolled out the other. Workers operated drill presses, rivet guns, and assembly jigs in a carefully choreographed process that transformed raw metal into flying machines. Women comprised a significant portion of the workforce. With men being drafted, aircraft plants recruited women aggressively. These women, immortalized as Rosie the Riveter, performed every job in the factory. They operated heavy machinery, read engineering drawings, installed complex systems, and ensured quality control. Many had never worked outside the home before the war. Now they were building the most advanced aircraft in the world. The recycled aluminum they worked with performed exactly as required. Rigorous testing proved that properly processed recycled aluminum had the same strength, fatigue resistance, and durability as primary aluminum refined from ore. The donated cooking pots and car parts, once transformed through smelting and alloying, became indistinguishable from virgin metal. Quality control inspectors couldn't tell the difference, and neither could the aircraft. By 1943, the production numbers were staggering. American factories produced over 85,000 aircraft that year, more than double what they'd produced in 1941. B-17 production alone exceeded 8,600 aircraft. Each one represented not just the aluminum in its structure, but the industrial coordination that made that aluminum available. From collection drives in small towns to processing facilities to aircraft plants, millions of Americans had contributed to putting those bombers in the sky. The strategic impact was transformative. In 1942, the the 8th Air Force in England struggled to put 100 bombers over Germany. By mid-1943, formations of 300 or more became routine. By 1944, 1,000-bomber raids were possible. The aluminum shortage that had threatened to cripple American air power had been overcome through recycling, expanded production, and industrial efficiency. The bombers themselves proved formidable weapons. The B-17 Flying Fortress earned its name through sheer durability. The aircraft could absorb tremendous battle damage and return home. Stories circulated of B-17s landing with entire sections shot away, engines destroyed, and control surfaces shredded. The aluminum airframe, whether made from virgin metal or recycled scrap, proved remarkably resilient. Combat crews came to trust their aircraft absolutely. They gave them names, painted nose art, and treated them as living things. These men flew missions knowing their survival depended on the aluminum structure around them. That structure might contain metal that had been a cooking pot 6 months earlier, but it didn't matter. What mattered was that American industry had built these bombers in sufficient numbers to challenge German air defenses. The bombing campaign against Germany was brutal and costly. 8th Air Force losses were horrific, over 26,000 men killed in action. But the campaign achieved its objectives. German industry was disrupted, oil production was crippled, transportation networks were destroyed. The Luftwaffe was ground down in battles of attrition it couldn't win. By 1944, Allied bombers operated over Germany with relative impunity, systematically dismantling the Nazi war machine. None of it would have been possible without solving the aluminum crisis. The scrap drives, the recycling infrastructure, and the metallurgical expertise that transformed household items into bombers proved decisive. America's industrial capacity became the strategic weapon that overwhelmed the Axis powers. The ability to produce aluminum in sufficient quantities, through both primary smelting and aggressive recycling, enabled air superiority. The economic efficiency was remarkable. Recycling aluminum required only 5% of the energy needed to produce primary aluminum from bauxite ore. This energy savings allowed scarce electrical power to be allocated to other war industries. The cost savings were equally significant. Recycled aluminum cost approximately half what primary aluminum cost per pound. These efficiencies freed up resources for other military needs. By war's end, America had produced over 300,000 aircraft, more than all other combatant nations combined. This production consumed approximately 6 billion pounds of aluminum. A significant portion, estimates range from 10% to 20%, came from recycled sources. That represents 600 million to 1.2 billion pounds of aluminum reclaimed from scrap. Without this recycled material, production shortfalls would have reduced aircraft output by thousands of planes. The aluminum recycling program demonstrated something profound about American society. When faced with critical need, citizens responded with extraordinary generosity. People donated items they used daily, accepting inconvenience to support the war effort. This collective sacrifice, multiplied across millions of households, made strategic difference. The woman who donated her cooking pots directly contributed to air superiority over Europe. The program also showcased American industrial adaptability. Within months of recognizing the aluminum shortage, the nation built a collection and processing infrastructure that handled millions of pounds of material. Metallurgists developed techniques to efficiently recycle mixed aluminum scrap. Manufacturers integrated recycled aluminum into production seamlessly. The entire system worked because engineers, workers, and citizens collaborated toward common purpose. After the war, the recycling infrastructure largely disappeared. Aluminum was no longer in short supply. New smelters built during the war continued operating, producing abundant primary aluminum. The scrap drives ended. Citizens reclaimed their kitchens with new aluminum cookware, ironically often made from the same metal that had flown combat missions over Germany. But the lessons remained relevant. The war had proven that large-scale recycling was technically feasible and economically viable. The infrastructure and expertise developed during the war laid groundwork for modern recycling industries. Today, aluminum recycling is routine, with over 75% of all aluminum ever produced still in use through recycling. The techniques pioneered under wartime pressure became standard industrial practice. The B-17s built from recycled aluminum had varied fates. Some were destroyed in combat over Europe. Others survived the war and returned to America, where most were scrapped. The aluminum from these bombers was recycled again, entering civilian production as building materials, automotive parts, and consumer goods. The metal cycled from kitchen to bomber to peacetime products, an endless industrial reincarnation. A few B-17s survived as museum pieces or flying memorials. The Memphis Belle, carefully restored, sits in the National Museum of the United States Air Force. Visitors marvel at the aircraft's size and complexity. They read about her combat record, 25 missions over Europe, all crew members surviving. They don't know which parts of her airframe came from recycled aluminum, and it doesn't matter. What matters is that she represents American industrial achievement. The men who flew these aircraft rarely thought about the aluminum's origin. They focused on survival, on completing missions, on bringing their crews home. But some pilots, in quiet moments, appreciated the connection between home and front. The knowledge that American families had donated possessions to build their bombers created a tangible link between civilian sacrifice and military action. They were flying their nation's collective commitment into battle. For historians studying World War II's industrial aspects, the aluminum recycling program stands as prime example of total war mobilization. It demonstrated that modern warfare required not just military forces, but entire societies organized toward victory. The home front wasn't just supporting the military. It was directly enabling combat operations through material contribution. Without the recycled aluminum, the bomber offensive would have been delayed or reduced in scale. The program also revealed how propaganda and genuine patriotism could align. Citizens didn't donate aluminum solely because posters told them to. They contributed because they understood the connection between their actions and military success. The government's information campaign was effective because it communicated real strategic needs. When people saw newsreels of B-17s bombing Germany, they knew their donated cookware had helped build those bombers. The story of American aluminum recycling is ultimately a story about industrial improvisation under pressure. Faced with critical shortages, American industry didn't simply accept limitations. Engineers found solutions. Workers implemented them. Citizens supported them. The result was a production surge that overwhelmed Axis industrial capacity and helped win the war. Today, when we see aluminum products, we rarely consider the metal's history. But every aluminum can, every airplane panel, every automotive component contains metal that may have been recycled dozens of times. Some aluminum in use today might have originally been mined in the 1940s, served in a B-17 over Germany, and been recycled repeatedly through 7 decades of use. The metal is essentially immortal, cycling endlessly through the economy. The flying fortresses built from recycled aluminum proved that strategic capability could emerge from unexpected sources. American housewives probably didn't imagine their cooking pots would bomb Berlin when they bought them at hardware stores. But under wartime pressure, civilian possessions became military weapons. The transformation from kitchenware to bomber to victory illustrates how total war demands total mobilization. The fundamental lesson remains relevant. Industrial capacity is more than factories and machines. It's the entire infrastructure that provides materials, processes them, and manufactures products. In World War II, that infrastructure extended to every American home through scrap collection. The difference between victory and defeat sometimes depends on mobilizing every available resource, no matter how humble. The American engineers who designed the recycling processes, the workers who sorted and smelted the scrap, and the factory workers who built the bombers all contributed to victory as surely as the combat crews who flew the missions. The housewives who donated their cooking pots were strategic participants in the air war over Europe. Their aluminum, transformed through industrial alchemy, became the metal storm that darkened German skis and brought the war home to the Reich. In the end, the story of scrap aluminum becoming flying fortresses proves that necessity drives innovation and that collective sacrifice achieves strategic objectives. The bombers that won air superiority over Europe were built not just from industrial might, but from millions of individual contributions. From kitchen to cockpit, from civilian life to combat mission, American aluminum made the journey. And in doing so, it helped forge victory from what had seemed like insurmountable material shortage.